Hi, I'm Taylor. I'm going to talk about cohort modeling. Now, cohort really just refers to the act of breaking any sum into a component of a number of groups. A very typical use of cohort modeling in financial modeling and forecasting is time-based cohorts. So you can see how each time of user or customer or subscriber when they're acquired, how your profitability or revenues or retention or whatever they kind of change over time. And to see each kind of cohort separately, so you can see if there's changes in the performance of whatever you had you acquire things over time. And a very typical use of kind of a cohort analysis, looking back at like past performance of cohorts, very common to see a chart like this where you have like your users you acquire kind of per cohort going backwards, and then you see the performance of like the retention or revenues or whatever, or orders or whatever is going across our time. And you can see how different cohorts have performed as they've aged. Now in forecasting, the chart kind of gets flipped around in the sense that you will model out each kind of cohort kind of coming down, and then you'll see the cohorts kind of going forward. So as each kind of cohort comes, as they kind of age over time. This example is like as a revenues based cohort based upon a per month basis. You can see the performance of each cohort of new users that are acquired each month. You can see the revenues from them going over time, and it uses new user acquisitions and then a revenue assumption that kind of changes over time as well. Now, not hard to do if you kind of know how to kind of think about the problem and create the structure, but there are other tools to do kind of cohort-based analysis. There's a number of like web app tools that allow you to basically just like drop your data in there that will do analysis of the performance of your past cohorts. But for future looking forecasting, it gets a little bit harder. So I want to show an example of how to do this in Causal, because Causal has a number of functions and features that are built in to do cohort-based modeling. So we'll just go do an example of how to do a cohort model. Now, Causal has a way, if you have a set of like historical cohort data, to drop it into like a Google sheet, link it to Causal, and Causal then can automatically create data analysis from it, and you use that data to do like forecasting from it as well. But I just want to show a simple example of how to create cohort-based forecasting. So we're going to start off by creating a couple of basic structure for, let's say, new users. And then retention. And then revenues per user. So for new users, I'm going to say if time step equals 0, then 100, else new users times 1.1. And what I'm doing here is I'm basically just saying, hey, if it's the first period, just put as 100 new users. If it's not, then do however many users there were before, increase it by 10%. If you could also skip the if-else part and just create a form when you used previous, Causal would automatically recognize and say, hey, you need to actually create an assumption for the first period and kind of prompt you for it. So that's an easy ways to do that. So I forgot the time step part. Perfect. So retention, we're going to do the same method for it. If time step equals 0, then 1 means 100% retention on the first month. Else retention previous period times 0.95. So it's just like going down by 5% per period. So this is on a per cohort basis, kind of creating this retention curve coming across there, where it just continues to kind of go down by 5% per period. It creates this kind of shape. And revenues per user, I'm just going to assume, for the moment, I'm just going to assume 5. So now I'm going to add a calculation here, which is, okay, well, let's figure out total users, right? So users, this is going to be equal to if time step equals cohort. And then I want the number of new users per that cohort. If it's not, I want users times retention. So if not, I want to apply the retention curve. And the retention curve, instead of just saying it's current retention, I actually want to create a lag effect. So I'm going to say T minus cohort. And so if I open this up to see it, I can see each cohort basically starting at 100, then churning down 110, churning down 121, churning down 133, churning down. So I can see like that usual kind of churn. And now for calculate revenues, one simple way is just to say it's users times revenues per user. And then if I open this up again, I can see the revenue per user. Now, if you're not just going to assume that average revenue per cohort is the same 5 going across, or if you perhaps want to model out like a land and expand strategy where you land someone for something and you expand the revenue from over time. Now, by doing things on a cohort basis, you can do all the kind of detailed calcs. So here, instead of like assuming 5, I'm just going to assume revenues revenues per user previous times 1.05, and now I'm just going to type in 5 in the first period. Now I actually start to see this kind of growth going in over time, and now I start to see this numbers going over time. Now this is going to apply the new. This actually doesn't do it on a cohort basis. This just says, hey, every user pays this amount per period. If I want to make this revenues per user a lag-based effect to show that like you land all new customers at 5, then over time each cohort of users changes over time, I can change this formula, right? So instead of saying it's revenues per user current, I can say it's T minus cohort, and then I'll do users. I think for this one I have to do, let's see here, not that. For this one I think I have to do 2T minus cohort as well. And so now we see an effect here where you're acquiring, like you're getting 500 and it's going down, and it's actually not going down by a lot because it's a combination of churn in users but also increase in revenues. So you actually can kind of understand how they operate independently, and then see like the total here, and then the total revenue line right here is be reflective of the sum of all the cohorts. And so this style of methodology is really great for being really clear in terms of how your calculations work. And I just want to show you how Causal makes it easy to do. If you have questions, ask anytime.